there are quite a few points of confusion when first learning new functions. Let's clear most of those up with a single example. What I'm going to do is create a blueprint callable function and add a lot of parameters and output parameters. So I've defined this function. Let's give it some parameters. We can do pass by value. We can do by mutable references. So mutable references are actually viewed as output parameters. If you actually want a mutable reference as an input parameter, what you have to do is do UPARAM ref, and then we can do in32 reference. We can also do constant references. Now, this function is also returning a float, so we can actually name that float by doing UPARAM DisplayName, and we'll give it a blueprint-friendly name. And so if we give this a body, let's compile this and see what it looks like in the editor. So the name of it was not overwritable. And we can see that there's actually two return types. If we look at the C++ signature, we are just returning a float. But here we are returning a float, the myReturnFloat, which is what we defined as the name using the UPARAM DisplayName, but we're also returning the mute ref, and so that is this thing. But notice this was also a mutable reference, and in this case, because it is prefixed with the UPARAM ref, it makes it as an input parameter to this node instead of an output parameter. Notice that the const ref is also an input parameter. So the only difference between the const ref and the mute ref is the presence of the const keyword, which is enough for Unreal's editor to determine this to be an input parameter instead of being an output parameter. The pass by value also has a subtle implication. By value, notice you can type a value here, but the const ref you cannot. So sometimes when you want a node to be directly typed into, you can specify the input as being by value instead of being by const ref. Notice also that while this is virtual and can be overridden by code, it cannot be overridden by blueprint. So if we go to the functions override, not overridable, in order to override this function, we would need to make it a blueprint native event, which requires it not be virtual. We'll get to that in a moment, but just so you can see it, this is overridable via code. So we've overridden this, and we can see it execute. So we've hit the breakpoint, and if I continue, we can see that the child has overridden the virtual function and is correctly executing it.